All right, on to the next type of t-test, the independent samples t-test. One sample t-test, one sample z-test, yeah, they're cute. They don't get a lot of use. It took me a day or so to find examples in the literature of their use. Independent samples t-test, however, is kind of one of the workhorse statistics, probably one of the big three statistics that we see, our big 4 or 5 statistics, I should say, that we see a lot of examples of. An independent samples t-test is for comparing means that are drawn from 2 separate groups. These would be 2 groups that have different people in them. That's what makes the groups independent in a statistical sense. And again, we're going to see some different formulas here, and the formulas here get a little bit more complicated. I think actually you're at an advantage because you're learning the formulas and you're seeing them. They're typed out on my computer. You don't have to put up with my crappy handwriting and trying to figure out what values I'm writing. So I think you got a boost in that way. All right, a couple of ways that will get at the differences between these tests. In a one sample t-test, we addressed the mean in a population, hypothesized mean in the population. Independent samples t-test is going to be a hypothesis about the difference between our two groups. And that hypothesis, if you think of a null hypothesis, well, if it's following that theme of the null being no effect, the null hypothesis will always be here that there's no difference between the 2 groups, or that the means are equal. So typical questions we might ask, do middle school children in Humboldt, are they reading at a 7th grade level? Whereas a typical question we might ask with an independent samples t-test would be something like, do middle school students in Humboldt differ in their reading level from middle school students in Mendocino? Again, those are independent groups. They're none of the same students because they go to school in different places. So in plain English, for the one sample test, Humboldt County middle school population mean is 7. Plain English, null hypothesis. For the independent samples t-test, Humboldt County middle school population does not differ from Mendocino. More differences, you can see what the hypotheses look like. One sample t gets a specific value. Independent samples t is a statement about the difference between the means. You sometimes will see this as mu1 is equal to mu2. I like to always write it as mu1 minus mu2 equals 0. And the reason for that will become clear because that gives us an actual numeric value to compare against our confidence interval. The formulas for these, you can see that the independent samples t, what's different about the formulas is that it focuses on the difference between the means minus the hypothesized difference between the means on the top. That's the big piece. The denominator looks a little bit different. It's a little bit more complicated to calculate. It's not impossible. You can see the standard error gets more complicated. The standard error here is going to involve standard errors for 2 different groups. And then there's this minus piece, which we'll talk about when we get to the calculation. That minus piece actually doesn't really play into the calculation of independent samples, but by using that formula, we get to use the same exact formula for the independent samples and the paired samples test, which I think is always desirable. Degrees of freedom, one sample t-test is n minus 1. Independent samples t-test, n1, the number of people in the first group, plus the number of people in the second group, minus 2. Oh, and then for some reason, the confidence intervals come up last. You can see our new confidence interval begins with the difference between the 2 means on the left-hand side, our t-value, and then our standard error. One thing to keep in mind with these confidence intervals, it's always going to be very consistent. The left-hand side is going to be whatever's in the null hypothesis. The right-hand side, or the margin of error, is going to have some value from a statistical distribution, z or t, and then it's going to have some aspect of standard error. It's always going to be those things. All right, again, independent, that just refers to how the groups are constructed, different people in each group. For example, we might take 100 people, assign 50 to receive a treatment, another 50 maybe to go on a waiting list. Compare 7th and 10th grade students on math achievement. Those wouldn't be the same students. Not independent would be situations where you've got where you've got the same people in both groups, or even if it's just one person in both groups. These have to be completely different groups of people. All right, so let's take a look at an example. This is from an actual study, researchers studying aggression. Researchers studying aggression have to develop some really clever ways to do things. So I'm kind of into that literature, even though that's not what I study, just because they're so damn creative. So in this study, participants came to a lab and it said, okay, you're coming for a taste preferences study. They sat in the waiting room with 2 other participants. However, those 2 participants weren't actually participants. They were Confederates. That doesn't mean that they fought in the Civil War on the wrong side. That means that they are part of the experiment. They're in on it. They're going to behave in a certain way that's part of the experiment. You, as the participant, don't know this. The real participant was assigned to experience either ostracism or inclusion. Ostracism is when you're just left out of something. And inclusion is, of course, when you're part of it. So one of the Confederates removed a toy from a basket that said children's play study and began a game where they were just tossing it back and forth. In the included condition, they just tossed it from one participant to the, they all 3 were playing with each other. In the ostracized condition, the 2 Confederates included the participant for the first couple of throws and then turned their backs to that participant and just played and ignored the participant. They then moved to separate rooms. And they were the participant was told that they would be packaging food for a taste preference study. And they drew a slip out of a hat. The slip always said that they would be packaging hot and spicy food. They were presented with a bowl of hot sauce, cups, lids, and a spoon. The participants allocated the hot sauce according to the written instructions. The sheets indicated whoever was tasting it had to consume the entire sample as it was packed, but the participants should read their taste preferences, which were presented in a sealed envelope as part of the packet, to figure out whether that person was allergic to what they were trying to serve them. One thing to note here is clear that the person tasting was not the other participants. At this point, you as the participant still believe that those 2 people who excluded you are in another room doing the same experiment. So all of the participants also read a slip that the taster rated hot and spicy food as a 3 on a 21-point scale. Pretty close to the extreme dislike of spicy food. The participants tasted the hot sauce to verify that it was hot. After filling the cups, the sauce was weighed in an adjoining room with a scale. And the way that they measure aggression here is how much hot sauce they packed. How much hot sauce they packed for the participant to have to eat. That was, I think, a pretty cool way to measure hot sauce. They were told the participant didn't like spicy foods. They were told that they'd have to eat it all, and the hot sauce was pretty hot. So what did the results look like? Well, first, the null hypothesis is simply that the 2 groups will serve the same amount of hot sauce, show the same amount of aggression. So you can see the null hypothesis there, mu1 minus mu2 is equal to 0. What's cool about independent samples and paired samples t-test is that's always the null hypothesis. You don't have to remember anything else. That's always the null. Here are the results. These are in milliliters of hot sauce. I'll show you what a milliliter looks like in a little bit, because I know most folks don't know what a milliliter is. I barely know what a milliliter is, aside from various things of alcohol. The big thing of alcohol at Costco is 1.75 liters, about the limits of my knowledge. All right, so the ostracized folks served an average of 28 milliliters, whereas the included folks an average of about 4 milliliters. Do the groups differ? Well, we don't know. Is this enough difference for us to say, wow, this wouldn't happen very often if the null hypothesis were true? That's the real question we want to ask, not just looking, oh, well, they look like they differ. All right, Standard error of the difference, the first part of the t calculation. This looks like a lot, so I want you to definitely spend some time with this slide as you're doing calculations. But I'll go through it. These formulas look big and scary, but they're not that difficult. There's just a lot of places to mess up. The pooled standard deviation. We'll talk about this value in a little bit, what it means. But for now, we'll just give it a name. The pooled standard deviation is the first thing we want to calculate. This involves our group standard deviations and their sample sizes. So we're going to take the first group standard deviation, we're going to square it, and we're going to multiply it by that first group sample size minus 1. We add to that the same values from the second groups, and then we divide that by the two sample sizes added together minus 2, or the degrees of freedom. And then we take the square root. And you can see once we do that, we get a value of 18.46. One thing that's nice about this value is that we actually use it in another formula when we get to what's called the effect size. So it's kind of helpful that it's at least getting used twice. SX1 and SX2, those are the standard error for each of the groups. That's simply the pooled standard deviation over the square root of the sample size. And you can see that these will always come out to be the same thing if you have equal sample sizes, 4.128. Finally, the last part here is the standard error of the difference between the means. That's the first standard error plus the second standard error, both of them squared, minus 2 times R times the two standard errors. What's R here? R is the correlation between our two groups. And this is something that actually for every independent samples t-test is going to be exactly 0. It's going to always be 0 for independent samples t-tests. When we get to the paired t-test, that value will take on we will have a value there because we'll have the same people measured twice, and we'll know how well their score in time 1 is correlated to their score in time 2. Final thing I got on these slides, the degrees of freedom, just adding the two sample sizes, subtracting 2. All right, that's the first part of the calculation. That's the hard part. 95% confidence interval. Difference between the means, our t-value, and again, this is the t-value that captures 95% of the distribution, and that standard error that we just painstakingly calculated. You can see we just plug those values in, and we get a confidence interval here of 11.3 to 34.9. That confidence interval represents what we would expect the differences between the groups to look like. And the way we draw conclusions about this is that we compare it to the value in the null hypothesis. If this confidence interval includes 0, we would fail to reject the null hypothesis. But it clearly does include 0 here. Does not include 0, rather, I should say, here. 0 is well outside of this confidence interval. What does that tell us? Well, it tells us we can reject the null hypothesis. In plain English, it tells us that ostracized people showed more aggression. They served more hot sauce than did the included people. We could also do this with a t-value. Here, it's just the difference between the means minus the hypothesized difference. It's not written in there, but that hypothesized difference is always 0. We divide that by the standard error of the differences. We get a value of almost 4. And you can use this little piece of code to get the probability there, 0.003. That's well below our threshold of 0.05. So we would reject the null hypothesis in that case. In terms of output here, in terms of interpreting this in terms of output, you can see that we get our t-value, our degrees of freedom, and then also the confidence interval down below. And within the tutorial, you can see the code for running this analysis. For some reason, it's not included here. Again, that confidence interval, what that is telling us is that we reasonably expect the population difference to be somewhere between 11.3 and 35. So what I really like about those confidence intervals is not just saying that ostracized were people were more aggressive, it's telling you how much more aggressive they were. Similarly, the t-value, just showing you how you would present that in APA style. Again, same decisions.